Okay, this is number 33 in section 2.5, and we're solving an initial value problem. And hopefully solving an initial value problem is familiar to you because we've done it with a homogeneous differential equation. So now we're just dealing with a non-homogeneous differential equation. So we're going to be adding that particular solution. If you want another example of solving an initial value problem with an NHE, non-homogeneous equation, you can look at example 6. It gets a little bit ugly, but it's a good example. Obviously well written by the author. So please take a look at example 6 if you want more practice, which I encourage you to read. Okay, so let's solve this initial value problem. So, 80% of the work we already know how to do. It's just, right, finding the sum of these guys and then using our initial conditions. Okay, so our characteristic equation, it's not going to be bad. Now we know, right, we've done this many times. R squared plus 9 equals 0. Okay, so we know that R squared is going to equal negative 9. R squared, not R squared, R equals plus or minus the square root of negative 9, which we know is going to be 3i. And, right, we can write this as 0 plus or minus 3i, where this is my a and this is my b. Again, we have the a plus bi form, where a and b are real numbers. Okay, so let's write our y sub c. So our general solution to our homogeneous equation is the following, is C1 times e to the R1x. Actually, just kidding. It's not going to be that because we get a complex solution. We don't have distinct real roots here. So our complex solution from one of your theorems, I think in 2.3, I want to say it's theorem 3, I used it before, is going to be e to the ax. So e and then a is 0 times x times c1 cosine bx, so that's cosine 3x, plus c2 sine bx, which again is 3x. And again, notice this is just going to be a big 1. So this is just, we could distribute the 1, which really doesn't do anything, because we get the identical expression. Okay, so again, hopefully, right, this is familiar. This is the yellow part that I've been writing it as, boxing it as yellow. So now let's try to construct our yp. So construct y sub p. So we choose y sub p. Well, it depends what our f of x is, and right, this is our f of x, which is sine 2x. So I'm going to have a sine 2x involved there. So probably a, and then we have cosine 2x plus b sine 2x. And make sure you include the cosine x. Don't just write b times sine 2x because you see sine 2x. Because remember, you're going to be differentiating, and when you differentiate sine, right, you get cosine, and so you're going to need that cosine of 2x. Okay, so let's differentiate. And we have y prime. Okay, so derivative, so we're going to, this is just chain rule. So it's going to be negative 2a sine 2x plus, let's see, 2b cosine 2x. And then we have y double prime, which is negative 4a cosine 2x plus 4b, and actually it's going to be minus. So let's just go ahead and write minus 4b sine 2x. And hopefully didn't make a mistake, sine, cosine, sine. Okay, so let's substitute this back, right, into our equation. So let me, right, this guy is going to go back into the non-homogeneous equation. And I believe was, let's see, 9, so y double prime plus 9y, okay, equals sine 2x. So y double prime is right there. So negative 4a cosine 2x minus 4b sine 2x plus 9y. Okay, well, here is my y. So I'm just going to multiply it by 9. I'm distributing 9. So that is going to be 9a cosine 2x plus 9b sine 2x. And then, of course, that's equal to my f of x, which is sine 2x. Okay, so can we combine, any like terms, right? Collect all the coefficients. Let's see. We have cosine 2x. We have a cosine 2x, so that is 5a cosine 2x. And then we have sine 2x, so 9b minus 4b is, again, 5b sine 2x. Okay, so let's equate these coefficients. We definitely have, sine 2x and sine 2x. So we know that 5b is going to be equal to 1, right? Because we have our, let's maybe make green. Here's our 5b, right? The coefficient, and this is really a 1. And then we have our, let's see, maybe make it pink. We have 5a, and then the coefficient of the right-hand side. This is really, we don't have to write it, but this is really, we have 0 cosine 2x's, right? Because we have none. So that's going to be my 0. So it's going to be 5a equals 0. And this is nice because b is 1/5, and then a is 0. So let's substitute this back into our particular solution that we chose. So, oops, so here is my yp. So y sub p is a cosine 2x. Okay, a happens to be 0, which we know is going to be gone, but I want to write it in, plus b, so b is 1/5 sine 2x. So my particular solution to this non-homogeneous equation is 1/5 sine 2x. So I found my y sub p. So again, all we have to do is, again, right, usually I think I called it step 3 in our previous examples. So yc plus yp, and yc, I believe, involved, right, was my yellow. So let's see, cosine 3x sine 3x. So c1 cosine 3x plus c2 sine 3x. And then, of course, I'm adding my yp that we just found. And here, note, we don't have a case of duplication, right? Because here we have sine 2x, and here we have sine 3x, right? Or cosine 3x. If this was a sine 3x, then we would have a case of duplication. But, we have sine 2x. And I'm going to stop here, and I'm actually going to continue in the next video just because it's, well, I'm almost at 9 minutes. So you can see the first part. The last part is actually not too long, so I'll continue it in the next video.